usually I would say you're talking Greek and Latin. I think I'm going to say you're talking cloud native CI/CD to me. So that was on a lighter note. Thank you. I think I'd like you to be on the stage, and I'd like to welcome Mr. Mayank Chaudhary, from Impact QA, the VP Sales and Marketing. Thank you.
Thank you. I appreciate it. Thank you. Thank you.
Thank you once again, both of you. For all of you who are still wondering how far we are from the cocktails, there is still some time. So you have to bear with a couple of more presentations, but hang in there. So the next session is going to be a little info on 5G. We all know 5G is an emerging reality now. With emergence of 5G, how are we dealing with architecture and software stack is a big question. It's a pleasure and honor to host Mr. Atahar Khan, Senior Solutions Architect from Cisco, to help us understand the nuts and bolts of 5G. A very warm welcome, Mr. Khan. We request you to now come on stage. Please, let's put our hands together. Thank you.
Thank you for having me here. Good evening. So she has already introduced me, so I'll not waste the precious time of 25 to 30 minutes. I'll jump to the agenda. I'll be talking more on the nuts and bolts of 5G. So we are not actually going into the, the screws and bolts, but actually my previous speakers have talked about the cloud native, the edge computing, and a lot of other software stacking. So I'll be trying to connect the dots in the perspective of 5G. Everyone is actually eagerly waiting for a 5G to come, and I hope in the next conference we'll have all the 5G signals here. So with this, that will be the agenda. I'm going to cover it. I'll be giving the connecting dots of 5G with this, starting from the RAN, right from your mobile handset or the the active users, and then get into the packet core. That includes the multiple domain. 5G is a very broad topic, but I'm going to touch upon the very key concepts of 5G, how and what changes are happening in the 5G space. So the overall architecture, software stacking, and then we'll get into the network slicing piece. So let's get to the first topic. So what 5G is bringing in? So 5G is bringing in, there are four major things. There are a couple of use cases we have talked about. We are all hearing about connected homes, connected remote healthcare. There are a lot of use cases of it. But now what technically it is changing? So technically it is bringing more spectrum, frequencies, network, and new avenues of services. There are multiple services are going to come up. So today, if you see, most of the MNO or service providers are going to have more and the revenue coming from the consumers, the 70%, and the enterprise is actually 25 and 5%. So with the 5G coming in and more use cases are coming into picture, the vertical business and the revenue is going to grow. So that's how the prediction is. So what more is the spectrum? So in the spectrum space, we are going to have the mid band, which is called the sub-6, and we're going to have the high band, which is more than the 25 gigahertz of the frequency. So with that frequency, we can have more capacity, and the dollar value, the per bit dollar value or a rupee value is going to grow low. So that's the first change is going to happen. The second is the new radio. What you're going to get, as more and more users are getting more data hungry, and more data is being utilized. So you need more capacity, and that's what we're going to get the high bandwidth with the 24 gigahertz of the frequency in the range. And there are new technologies, and new technologies used like beamforming. As and when wherever you follow, your network will also follow you. You get the capacity. Now the third thing is the new network. There is a way to deploy the 5G The traditional way of a 4G or a 3G way may not work because it's all the centralized location. Most of the data is placed at the central location somewhere. I mean, if I talk about this context, right, in Delhi or in one of the state like let's say Haryana, or the data centers are placed at one location, which is the the capital of the state. But with the 5G, the data has to be kept closer to the user. That's why we need a change, or the previous speaker has spoken about the edge computing. The data will be placed closer to the user, not far to the user. This is where we will get the latency into picture. If somebody is doing a remote surgery, sitting in US and doing a surgery in India, they need a very, very low latency. If it is a connected car, the earlier example was given, if there is an obstacle, the car is coming, you need an action immediately, you need a latency, you need a less than 1 millisecond of a latency. So that's how we're going to change what 5G is bringing in. Now with this, we have a 4G. What is special, or architecturally what is going to change in the 5G? The main thing is the scale. It's not just the mobile phone, it is not just the humans talking to each other, it's a machine going to talk to each other, which is going to bring millions on millions of devices going to connect to each other. And this is where we get to the distributed architecture, not the centralized architecture. And then there are slicing. The slicing is, there is a mobile slice, there is an enterprise slice, there is a healthcare slice, there are multiple slices. What slice means is a different attributes and a different treatment. If I give you a terminology like we have all come across the the freeways or highways. We need a special lane for a high quality of a service. If an ambulance is coming, you need a very low latency, and it has to reach data faster from one location to another location. So these are the different use cases, and these have different attributes and different parameters. That's how the slice is going to be defined. Now it is actually a more data hungry. You can't have just a Mbps or a kbps. You need to have a more and more bandwidth. So with the 5G, we can go up to the 1 Gbps of a capacity. Now everyone is talking about the cloud native. The service provider or MNOs are going to use the cloud native technology. They're going to keep the data center or the content closer to the user, not in the centralized format, but into the distributed architecture. We'll cover it in the next slides. And how it is going to be in the cloud native, it's all going to be containerized. We have already done the virtualization in the 4G space, but now in the 5G, we're going to containerize it. And containerization and lot of scale, it has to be done with the automation. The story is incomplete without the automation. Now the microservices. The microservices is going to connect more and more services, not just mobile phone as a machine, factories, healthcare, all of those things. It will be connected as a microservice. So all of those things are going to change the architecture. Now let's take a deeper look into the architecture. So this is a typical architecture of a MNO or a service provider. So what happens here is we'll start from the RAN. You get the signal on your mobile phone. As of now, you see the LTE or a 4G. Now, once we have the 5G in place, you will have a 25 gigahertz of a frequency with multiple cell sites. In just one Leela hotel, we will have a multiple cell sites placed so that you will get more and more capacity, more data, and more users can be covered. So that's what we're going to use the access part of it, or a RAN part of it. Now coming to the closer to the transport. In the transport, it is not just a backhaul, or not just the tower is sending data to the central location, but it's going to have chunks, or the backhaul, which is usually called, if this is going to be divided or decoupled into 3 different pieces, which is a front haul, mid haul, and back haul. And then it goes into the centralized data center where all the the internet peering and all of those things. So I'm going to use the terminology which is the extreme left hand side, which is a far edge data center. The second one is the edge data center, the regional data center, and then the centralized data center. That's how I'm going to refer to this in this presentation. And we have a virtualization. It's not just the physical boxes going to sit together. It's all virtualized. Those who are familiar with the mobility technologies, there are concepts of data unit and a control unit that is already decoupled in the 4G. Now we're gonna utilize this. We're gonna keep this into the containerization NFVI platform. So how are we going to do it? Let me start with the RAN side. What is happening in the RAN side? Look at the bottom one, which is the 5G RAN deployment options. As and when we are going to the split option, the bandwidths are going to be lesser. But more and more preferred option is the split 7. Split 7, the 3GPP actually says that 7.2 is the more optimal one, because this is where the split is happening as the the optimal way. We can get more bandwidth as the eCPRI is also coming into the picture. Now, the deployment option. The deployment option is you have a 5G tower, there is a standalone and there is a non-standalone. In the standalone is just a 4G or a 5G. You can have a 4G tower, but your the packet core is the 5G upgraded, or a vice versa. You have a 5G tower, the frequency is allocated, 5G is tower, but still you are using the 4G as a core location. So vice versa is also possible, but you have to compromise on the bandwidth. So that's called the standalone option. The second option is the non-standalone, which is a more optimal one for the existing user. You can have a combination of both 4G and 5G, and then the packet core can also be upgraded as per the feasibility of the service provider. So we have a multiple combinations here. The more optimal one here, what we have seen across the globe, is the option 7, which is a more prominent one. So that's a deployment option on the 5G. Now here is the crux of the overall architecture. If I look at, as I said, the BBU is decoupled. BBU is used to be the baseband unit. It has to be a box, but now this box is decoupled. The control unit and the data unit is actually placed on two separate locations. If I give you a context here in the NCR, for example, if we are sitting here in the Ilila Palace, the VDU is placed here because we want to keep data close to the user. We want more bandwidth. We need more less latency. So one VDU can be connected or can map to multiple radio towers. Now, multiple VDUs can also be connected to the multiple VCUs, and then it is also mapped to the UPF. So that's what one decoupling or a decoupling is happening. The BBU is splitting into VDU and VCU, and the second decoupling is happening at the packet core, which is a CUPS architecture. It is happening on UPF is splitted and the control plane, the user plane and the control plane. So that's a two split is happening, one on the RAN side and the second one is on the packet core side. That's a two split is happening. Now, the advantage of disaggregation is it used to be kind of a proprietary of a certain vendor in the RAN architecture. But with this open architecture, you can have a hardware from one vendor, you can keep the NFVI layer of a one vendor, and then the application of another vendor. It's all open. Nobody has a proprietary. And it's all open standard interfaces between the hardware and the NFVI layer and the applications. It's all open standard. It's not coupled with particular vendor or a proprietary interface. It's all open interface. That's the advantage here we're going to get here. Now, when we talk about multiple use cases, in the use cases like private 5G is one of the use cases. The industries, the healthcare, all of those things can have the private 5G. They have their own private spectrum or a private network altogether, just like a public 5G. And then if you look at new service enablement, I have already talked about not just a mobile, but we have a multiple applications, connected cars, connected homes, all of those many applications can come in. Now software and hardware is already decoupled. We're going to leverage it here in the 5G as well. Now up till now I have given you the dots, RAN, packet core, transport and the control or packet core. Now we're going to get into the 5G stack. How we going to build a stack of a 5G? As I said, there are many number of cell sites or a microwaves towers. It's going to have typically in thousands, and then thousands of edge DCs are going to connect it to the regional DCs or a regional data center. That will be in hundreds. And the central data site is going to be a tens or a very small in numbers. And how we going to build it? It's going to be on the, it could be on a cloud, private cloud, or it could be on a public cloud. And what cloud is going to bring in? It's going to bring in the agility. You can increase the capacity whenever you need it. You can decrease it based on your requirement. And different vendors are treating, giving a different names, but this is a generic architecture. What you're going to get it here. You're going to keep compute storage at the all the DCs. And once the NFVI layer is built out, being on be it a private or a public cloud, you can keep all the applications of a mobility. And then we're going to use the APIs to connect all the dots together. And with all the complete framework is incomplete without the end-to-end automation. You're going to have different domains, a RAN domain, a transport domain, the 5G packet core, and the cable. All of those domains is going to be automated. All the huge scale of a 5G is not possible with the manual effort or doing a traditional way. It has to be an automation way. That's what we're going to bring in the in the next section. Now let's take a deeper view of a 5G stack. We all talked about we're going to keep everything in the cloud locations. So I have given an example here. We can build it on the hardware or a bare metal. We can build the NFVI layer on a on a private cloud, or we can keep the similar applications on a public cloud as well. So all of those things possible, and it's called the 5G core on the cloud native. So that's what we gonna propose to customer, and there are many customers are already using this type of a stack for 5G. Now the slicing part of it. Now what slicing is actually let's say a slicing. We have a one event going on, so that can have a one slice. Mobile is a one slice. Enterprise data is a one slice for a provider. So when we all machines are connected, the service provider or the nodes has to be differentiated in a certain way, and then it is mapped to a particular slice, and that slice will provide a different treatment or a different attribute to the user. As if I give you the example again to clarify it, on the highways we have a multiple lanes. The ambulance is a priority lane. That could be a low latency slice, which is called the URLLC. In the 3GPP term, it is called the URLLC. The second, which is a more common one for a mobile, the enhanced mobile broadband. So that's the second slice. The third slice is called the MMTC, which is a machine-to-machine communication. That is a third slice. That's typically three slices are actually captured in the standard. But service providers are free to capture more and more slices by having a different attributes and different characteristics of a slice. And slice, when I say slice, is not just a one particular domain. It has to be an end-to-end, right from your UE, which is called a mobile in our general terms, right from our UE to the packet core where you reach to the content. If you are accessing a particular content, you need to have a similar kind of a slice crossing across the domain. The domain is, and this is all standards are captured in the TM forum 639, the standard one. We have a one domain which is called the access domain or a RAN architecture. That's a one domain. We have a NST. And then there is another domain which is called the transport domain, and all the switches and router. And the third is actually the mobile core. So that's a three different domains, and each have their individual controller, which is in the slicing terms, it is called the NST, the network slice, network sub slice template. And then there will be a master one, which is sitting on the top. When the request comes for a slice, that has to come from the top, and then it is distributed across multiple domains. And then it's going to be stitched together. The RAN is going to be stitched to the transport. Transport is going to be stitched together with the core domain. And it's all standard and defined in the TM forum 639. Now coming to the options. when we talk about the slices, we have options of a hard slice or a soft slice. By looking at the terms hard and soft, you can easily figure out hard means something is dedicated, right? You have something cannot be shared. Now, on the soft slicing is the resources in terms of a cloud native. You can take it in the context of be it on the RAN side, core side, or a transport side. The resources are shared. If many of you are from the software background, you have a compute, you have a memory, you have storage. So it is not unlimited, right? You have a limited capacity, and it has to be shared with the different applications. So that is the concept in the slice as well. You can apply, the resources are shared. It's not dedicated for a particular slice. Now, similar way, we are talking in the, the terminology is same, the hard slice versus the soft slice. And soft slice is more optimal because you can leverage your existing capacity and availability into the soft slicing piece. Now, if I again go back to the 5G terminology, we have the standard defined in the Open RAN xHaul. This is particularly in the context of the transport or xHaul of ORAN. How the slicing is going to be defined here? The slicing is going to be defined right from your packet core till the RAN, and you have multiple standards formats, which is a different interface like F1U, which is, and then N3, N6, and E1. All of those interfaces are defined. On the top, if you see, this is a non-slice. This is a shared slice. You have a common slice for these components, but at the bottom you have a separate slice. Again, if I give you a realistic example, if you want to, let's imagine this is a mobile slice, this is your enterprise slice, this is a healthcare slice. And each of these slices is going to give you a different attributes and different experience. And this is how service provider is going to provide the different slices and different experience to different slices. Now, in this context, if I take you again one more level up, how are you going to deploy the slices? My topic is nuts and bolts, so I am getting into the details of it. How are you actually going to deploy this? When you are going to connect the VDU is going to talk to VCU, and VCU is going to talk to the UPF. How are they going to talk to each other? Again, they have a traditional technology like a layer 2 VPN or a layer 3 VPN. That's how we're going to connect the VDU and a VCU. But in a different fashion, it will have a different QoS, and it will have a different attributes. Now we have a segment routing in the transport domain. The transport domain segment routing is going to give you a low latency path with the traffic engineering. You just don't have a default path. You have a engineered path. You can define your own path with the segment routing. So that's how you're gonna and there are one point, this is the architecture of a phase 2, which is defined in the ORAN. The phase 1 is just talk about the slicing between the UPF and the VCU. But in the phase 2, we are talking the slices till the VDU. It's up to the provider how they're gonna deploy it. But these are defined in the Open RAN. Now, that's my leaving the questions probably. It's all the story of a 5G, as I said in the beginning, the incomplete without talking about the automation. In the automation space, you have again the same domains. You have a RAN, you have a transport, you have a the data center, be it far edge, regional, or a central data centers. Cable automation. Cable is one of the biggest headache for a service provider. Cabling from one server to another server, router to another router. All of those things that are very complex. It has to be automated in 5G. It cannot work without the agility. The last domain is the packet core. All of those domains has to be connected. There has to be a separate controller, and then the controller is talking to the master controller. And there has to be assurance part of it. How do we going to monitor it? If something goes wrong, there has to be a monitoring system. There has to be some kind of a feedback mechanism. If something goes wrong, there has to be a feedback and to correct it. It's like an auto correction has to be happen. All of those things is possible with this architecture, and it's all defined in the standards, and we're going to leverage it to define the to work out the 5G architecture. So with this, I'm leaving 3-4 minutes for questions. because I believe many of you might have some questions, as the topic is too heavy for a technical one, nuts and bolts of 5G. I'll quickly take you to what I have described till now. The RAN architecture, there is a decomposition happening, the split is happening on the RAN, there is a packet core split is happening in the RAN, in the packet core side. The stack of 5G, how are we going to leverage the telco cloud, be it a private cloud or a public cloud. And then we are going to talk about the end-to-end slicing. We have already, I've just explained the end-to-end slicing. Now, the last slide which I talked about is the cross-domain automation for 5G. So with this, I have 4 minutes left, and feel free to ask any question if you have.
You may raise hands and I'll bring the mic to you.
Hi, my name is Pankaj Bansal. Quick question. In fact, today we all are talking about the carbon footprint is getting increased because of these cloud solutions. Now, considering 5G is coming into the market, we know that 5G also requires more of computing.
Yes.
So, how are we planning to create an impact so that it can reduce further carbon footprint on that? Do we have any plan in terms of technology, not in terms of strategy? Of course, strategies are different. Like for 5G, there are rumors that they have an impact on radiations, but I'm not going by those theories. But as a technology, are we taking any measures?
Yes. So, whichever vendor you talk about who is dealing with the 5G, be it RAN, transport, or a packet core, when you keep your, build a cloud, anyway you are trying to cut down your footprint, right? No, you are not going to keep your own data center and build, consume the energy, space, and all of those, environmental effect. So keeping your workloads on the cloud itself is the one approach to save your environment. The second thing is, from the hardware perspective, there are the chip manufacturers are trying to minimize the power consumption used by the chips. I'll not take the name, but there are some manufacturers which are trying to minimize the energy consumptions. It used to take the 10x. Now the same chip is going to consume the 1x or a 2x of energy. So that's the effort is going on to reduce the energy and save the, when we have many hardwares deployed, we're going to reduce in this way. That's what I can say. But yes, there has to be some effect because the volume is huge, but at the end, we're going to reduce the power consumption used by the chips.
Thank you.
Any more questions?
Hi, Ashish this side.
Yes.
Yeah. I have a question on network slicing.
Yeah.
So basically, we have mid-haul and a backhaul, where we also have a different underlying technologies, like somewhere microwave is being used and somewhere optical is being used. So how you think that the network slicing will come into picture over there, and how much far we are from that particular area? Because network slicing has to be end-to-end, right?
Yes. So when I was showing you the slicing part of it, the slicing is not just a one domain like a mid-haul or a front haul. The slicing has to start right from your from the RAN, from the access network. So there has to be, there are some, I'm holding a couple of patents on the same area. What it talks about and what suggestions we have given the patents is there has to be a one attribute. So let's say if I have to identify a particular service or a slice, there has to be a common attribute across multiple domains. And if I take just one as an example, like a BGP is a commonly used protocol in most of the places. If I take one of the attribute, right, then you can have one attribute talking to a multiple domains, and you can identify a slice. And as you said rightly, it's an end-to-end. It does not apply to a one particular domain, doing it only in RAN or a transport or a packet core. It has to be an end-to-end.
Okay, thank you. I hope that answers your question. Thank you, Mr. Khan, so
you.
much.
Thank
And
you for
please
having
be on
me
the
here.
stage for a little more time. We'd like to honor you with a small token of appreciation. For that, I'd like to call upon stage Mr. Harinder Mishra, Vice President Operations, RPA Tech. We can keep the claps going.